Good evening, ladies and gentlemen. May I have you all to be seated as our event will commence shortly. In accordance to COVID-19 measures, please ensure that masks are worn at all times under the stage. Before we start, please put your mobile devices into silent or airplane mode, and if you haven't already done so, we will commence shortly. Good evening, esteemed panelists and guests, Chair and Senior Management of School of Electrical and Electronic Engineering, both physical and virtual attendees. Welcome to the AI Research Student Conference 2022 opening ceremony. My name is In Jie, I'm a Year 3 student, and I'm the chair of this ARSC 2022 conference. So it's my honor to be your MC tonight. Tonight, we are deeply honored to have our guests and panelists here. And we will start with an address by the President of MLDA EEE, followed by a plenary speech from Prof Chen Tsuhan. And last but not least, the panel discussion among our outstanding panelists. And we will end off the panel discussion with a round of Q&A, then we will move on to the virtual career booth. And now, it is my honor to invite the President of MLDA EEE, Mr. Andrew Sugong, to deliver his introductory address. Mr. Sugong, please.
Good evening, guest of honor, Professor Chen Tsuhan, esteemed panelists, distinguished guests, physical audience, and virtual attendees. I am Andrew, a final year NTU student majoring in electrical and electronic engineering, and I am currently the president of Machine Learning and Data Analytics Lab at the School of Electrical and Electronic Engineering, or MLDA EEE for short. As the president of MLDA EEE, it is my honor to welcome everyone here to MLDA's flagship event, the AI Research Student Conference 2022. And before we start this event officially, I would like to take this opportunity to share with everyone our initiatives and events here at MLDA EEE. So, MLDA EEE is a student-led club that aims to provide a platform to empower NTU students to pursue the application of machine learning, data analytics, and artificial intelligence. And we do so by providing them with a place to learn, apply, and connect with our industry partners and the academia. So, the first pillar is learn. To promote learning of essential concepts of machine learning and data analytics, MLDA has curated various machine learning workshops ranging from basic Python workshop to advanced deep learning workshop across various fields, such as computer vision, natural language processing, reinforcement learning, and many others that are not only useful for students who wish to start their journey in machine learning, but also for students who wish to upgrade their machine learning skill sets. And beyond academic training, we also focus on keeping our students up to date with the latest research effort and innovation in AI and machine learning. Hence, we have our own ML Insider series, where we invite renowned speakers, such as researchers or entrepreneurs, who are expert in their respective domains in AI to conduct sharing on their experience working in the field of AI. So, moving on to the next pillar, apply. We want our students to take what they have learned through our workshops and ML Insider series and apply it in the form of projects. Hence, we will support any of our students who wish to embark on any of machine learning or AI projects. And here are just some of the in-house projects made by our talented students. For example, on the top right, we have our own in-house face tracking drone, which can follow your face and detect your gesture at the same time. And on the lower right, we also have our own face mask detection device as well. Beyond projects, we also organize our own in-house hackathons, competitions, and challenges as well to spark passion and interest of the NTU student population in machine learning and AI. So, for example, we have had our own MLDA AI Football Cup, where students compete against each other on building the best AI model that can play football in a simulated environment. Last but not least, we work closely with all of our industry partners to bring about industry ad hoc projects, final year projects, internship opportunities, and even a PhD scholarships to our students through virtual career fairs and company sharing sessions. hence further connecting our students to the industry and showcasing the talent pool of NTU students to the companies. And this is done through our flagship event, Deep Learning Week, which started in 2019, and it is a week-long event dedicated to promote machine learning to the general public through our panel discussion with renowned speakers, virtual career fair, and also daily machine learning workshops on various topics. And in 2021, not only we managed to invite a panel of esteemed panelists to conduct a discussion on the topic of AI-driven future of Singapore industry, but we are fortunate to have the privilege to invite the Minister in charge of Smart Nation, Mrs. Josephine Teo, as our guest of honor, which received an overwhelmingly positive response with more than 1,100 people signing up. And to end off our Deep Learning Week, we had the largest student-led AI hackathon in Singapore, together with our sponsors, with a total prize pool of more than $10,000. So, beyond Deep Learning Week, we also want our students to be familiar and have a first-hand experience of AI research as well. Hence, we have our second flagship event, which is called the AI Research Student Conference, which was started in 2021, and it promotes AI research among undergraduate students through 3-day-long event packed with tutorial sessions taught by renowned professors in the field of AI, paper presentation sessions, and a mini AI competition as well. For this year, we are proud to have AI Research Student Conference 2022, held from today, 12 May, until 15 May, which are filled with tutorial sessions given by both local and overseas speakers, and an opening ceremony panel discussion with our esteemed panelists and guest of honor, Professor Chen Tsuhan, on the topic of next revolution in AI, future innovations. Moreover, we will have an all-new mini AI competition for this year as well, which is called the Battle of Yunnan, which is based on the Yunnan Garden in NTU, where participants will compete against each other to build the best AI that can play the popular game during the 80s called Bomberman, and the battle will be live streamed through our webinar session and also our MLDA's YouTube channel. So stay tuned and follow the latest updates on our social media. Once again, I would like to wish everyone here a pleasant and joyful experience ahead on AI Research Student Conference 2022. Thank you.
Thank you, Mr. Sogong, for the insightful speech. And it is now my privilege to invite the Chief Scientist of AI Singapore, Professor Chen Tsuhan, to deliver his plenary speech. Professor Chen, please.
Thank you very, very much for having me. Let's see. Does this work? Okay. Yeah, this is actually my first time giving a presentation like this to a hybrid group audience. We'll see how this works. Of course, for those of you in the audience, please feel free to interrupt me. I think of this more as a dialogue. For those of you online, I'm not sure how this is going to work, but we'll try. Okay. So I'll start with thanking Professor Tan Yaping for really starting this endeavor of getting the student group to be very, very proactive in promoting the field of machine learning, AI, and data science. I thank you, the MLDA at EEE for having me at this event. And for me, this is like a homecoming. I know any of you know that I just spent 2 years with NTU, actually a little bit more than 2 years with NTU a few years ago. For me, this is just, it's just great to come back. So what I like to do is to really, for me, this is not so much a speech, rather it's a way to sort of warm up the audience for what's coming up next, the panel discussion. So I just want to throw out a few things to get people to think. Maybe I'll show a few images so as to demonstrate what can be done with AI and all of that. At the end, I'm also going to play my role as Chief Scientist for AI Singapore to give you a very, very high-level overview of what AI Singapore program is all about. Okay, so with that, let me just start by saying what makes AI work? Or it's really a question, what makes AI work? Of course, many of us, including students in the audience, know that AI has really a long history, right? Started, depending on how you count it, 50, 70 years ago, depending on where you define the beginning of AI. That's the birth of AI, And then it went through this not so insignificant AI winter many of us heard about. Of course, in the last, I would say, 10, 15 years, it's almost come back and big and strong, right? Like, what does AI work this time that it did not work 50, 70 years ago? Anyone want to venture to answer that question? Or MLDA President, you and your team members should have the answer. What makes AI work this time in the last 10, 15 years compared to, say, 50 or even 70 years ago? Say again? Yeah, computation. So computation, the hardware, the software have now become much, much more available. Indeed, that's one of, I would say that's one of the most important reasons that makes AI come big and strong this time. Okay, the second point, oh, you have other things to say? Okay, so the second thing I will add to that is the availability of data, right? Really, if you think about neural network, what it was 50 years ago, what it is today, it looks pretty much the same, right? But what make it really, really powerful now is, in addition to computation power, the availability of data. However, I want to give you a third point that sort of makes AI this time much, much more interesting than, say, 50 years ago. It's related to the first 2 points, but we'll see how this one differs. I'm going to start with experiment. I'm going to show you, not yet, okay. I'm going to show you a flash of an image. I think it's going to come out for about half or maybe even a second. Pay attention to the image and tell me what you see after it goes out. Okay? You got half to 1 second. I don't know how I timed this earlier in the slides. Ready? Go. Oops. Sorry, I hit the wrong button. So I need some technical support. What do I do? To go back? To full screen? Okay, I can do it myself now. This way. This one. Okay, so now be careful. I thought by doing this, I will advance to the next slide. Okay, that one works. And then try again. Yeah, let's see. It's not working. Okay, you want to try? No, I just want to, let's come back to this. I want to do full screen. Full screen. Yeah, like that. And then next slide. Next slide. And then if I click, yeah, it comes back. I don't know why. Which slide do you want? The first one. Just go back to the first one. Yeah. Yeah. And then next slide. What do you do next slide? Yeah, I want to. Sorry. Yeah, that was good enough. Sorry. Okay, don't last too long. Yes. Okay, now I give up. Okay, so the idea is that, does it work? Okay, so how about this? Yeah, didn't work quite well with everything done this way. But you saw a quick flash of the image and you saw something. What did you see? Yeah, what did you see? You saw a picture of a kitchen. You saw probably the stove, whatever is on top of the stove. And it's pretty much like a kitchen setup, right? Now I'm going to just review the whole image. Take a closer look. What do you see this time? It's not even a real kitchen, right? If you look at all the pieces that make you think it was a picture of a kitchen, they were nothing to do with kitchen. They were all small pieces. Some of these are like a tin can. Some of these are Walkman. Some of these like small toys of a spider-looking kind of thing all together, right? So what's going on here, right? It turns out that human brain is very, very good at this. When you see an image real quick without time to analyze all the details, you are actually pretty quick in forming the impression about that image. And that's what makes this work. Of course, if I give you a little bit more example, this is also another thing that we as humans utilize in making things recognizable. What does these 2 words say? The cat. You need not me to tell you that if you really do character recognition, the center character in both words are actually the same. You won't be able to distinguish that. However, with the 2 words together, you could tell the first one is the other one is cat, even though the middle character actually are identical in both words. So along the line of the advancements of AI, really I want to add, in addition to advancing computation power, in addition to the availability of data, is what all of this, what we call contextual information that really make things work. And of course, those of us AI researchers, that's why we try our best to utilize the contextual information. Okay, go back to the easy days, right? This is really how image recognition, object recognition works, right? You're looking for a cow in the image. You come out with a template, you start moving around, right? How do we call this operation of moving the window around? Convolution, yes. Now we can tell you're all from EEE, right? Convolution, right? And that's what this convolutional neural network came from, right? If we can somehow utilize the fact that you have a window that you can move about, and on top of that, add the infrastructure of neural network, then things become easier, become interesting, become powerful. That one is easy said. What's more difficult is this, right? If you think about how this kind of template-based, convolutional-based image recognition methods, it works most of the time, but it doesn't work a lot of other times whenever you have any sort of variation. In this case, if you train your face recognition system with people without eyeglasses, once they put on glasses, it may struggle. Or worse, illumination, right? When you train the system with perfect illumination, but test it under poor illumination, it's going to fail miserably. Different poses, yeah, even more challenges. And for this, you really have to, I'm going to guess that a lot of these convolutional neural network things these days probably won't work very well here because of all the pose variations. It doesn't end there, right? Those of us who are really interested in studying images from the past, take a look at this. You see the horse. There's a horse before the trees or after the trees? Not so easy, right? This one, I think, I know you like this particular artist. I like him or I don't know, but very much. He always has this kind of distorted figures all intertwined together. That's actually going to make this contextual-based image recognition very, very challenging as well. Okay, since we're in Asia, may I also show you a few paintings. How many horses are there? Yeah, not so easy, right? Okay, now I see. Because of occlusion, because of scale variations, make things more and more interesting. Right. This is really hard. Okay, what do you see in this image? This one to me is the most interesting thing. If I don't tell you what you're looking for, what we are looking for, not so easy, right? But if I tell you we're looking for a dog with some pattern on the fur, do you see the dog? Do you see the dog now? Yes, that's where it is. Right? Again, this is just all this example to tell you how contextual information can be useful and how you can make things more difficult if you don't get it right. So maybe just one more example. This one I thought is most interesting. This is attributes Tony Toraba from MIT. This group of people studying images of very, very small sizes. This one, if you count the pixel, I'm going to say maybe 32 by 32. I mean, a small image. But there's a lot you can get out from this image already if I give you the context. Okay, starting. Context is there are actually people in the scene. That's the, how you call it, a priori information I give you. So now you see there are people. How many people are there? Okay. You can probably even go to say that whether these people are male or female. Can you tell? If you try harder, you can probably also tell their ethnic groups. Okay? And other than the 4 people in this picture, what else do you see? If I force you to use the context. A flag. I'm going to force you even more so. Which country of flag that is? Amazing, right? If you look at how many pixels you even cover that flag, not many pixels. But you were also good at, once given the context of people in a room, there's a flag, you're very, very good at deciding, that's going to be an American flag. So that's what all of us AI researchers are aiming at. Really, how much can we draw from contextual information, therefore come up with better inference? And this is really one thing I want to say. A lot of people draw equal sign today between AI and deep learning. I get that. I'm perfectly fine with that. But there's much more to AI than deep learning, and this is one example. Okay, so maybe the next few slides I want to show you a few recent work that has been happening in the field. I thought might be interesting in terms of inspiring the students to kind of look into this a little bit deeper. Here's another image. So I love to deal with images, and really that's where I can see that this contextual information can be really useful. If you look at this image of 4 people, if I simply throw out the question, how do you think they are related? It's quite obvious that you have a family of 4 parents and children having good time out in the field, right? If you compare that with another problem that has no context at all, face recognition of these 4, it's actually not that easy in comparison, right? Block out everything out, just to look at these 4 kind of stem-sized images of 4 faces. It's not that clear anymore. Again, another illustration of how contextual information can be utilized. And I want to now give you a little bit more detail about how we do this kind of research. First of all, we look at images. Oh, by the way, you can see these 2 images. Are they depicting the same group of family? Okay. Do you think they were taken about the same time? Maybe not same day, but same outing. Yeah, because how did you see that? Instead of saying that these were like 3, 4, 6 months apart. How do you see that they were from the same trip even?
Same shirt.
Yeah, they were in the same church, except one, the baby was not. Maybe the baby had a milk spill and all that had to change, right? But other than that, you can see this is from the same trip, right? Because most of it. I even noticed that in terms of positioning themselves to the camera, they tend to maintain that configuration. Did they do it on purpose? No. Go back and check your own family photos. You're going to see how consistent among your family members when you put out either selfie or photo taken, you always have that similar configuration every time. I mean, most of the time. Okay, so therefore, in terms of understanding image like this, we definitely look into a lot of contextual information that we can utilize. For example, we have the so-called pixel context. What does that mean? That means not only individual pixels, but also how they are related to each other. And you just did that now with your human eye, right? The 4 people all configure themselves in the same way so that you can get probably the same family, probably the same outing even. The location of the 4 faces. Okay, I should have mentioned that. Capture context, right? In addition to the images themselves, the pixels, you also get the GPS information, the day, timestamp, and all of that. Those are useful information later for image analysis. Social context. This is one that in recent years that has been looked into more and more, right? Just now, without even thinking, you said to me already, these 4 people are from the same family. Does it mean that you actually analyze the faces and say they look alike and therefore they're from the same family? No. I think it's mostly this kind of social contextual information utilized. What are this information? Right? The fact that male average height is about that, female height is about that, the fact that mother and child differ by that many years, and the fact that sibling between the average year difference is 6 years. You actually factor all of that information into analyzing image and say, wow, that means it looks like a family. How about this one? Does it look like a family? Maybe just way too many, right? So you say, okay, nah, okay, probably this is more like what? Maybe kindergarten, the teacher with a student from the same class. So you can see a lot of the social context information was utilized just now when you say the first image, the first few pictures were a family, and this one is a kindergarten teacher with students. So can we teach computer to do the same? That's what we do for research. So yes, this is actually not even recent anymore. Almost 10 years ago, we started with this effort of analyzing photos of human utilizing social context. Here are just some examples that I want to show you in terms of the results of performance, right? It turns out that if you want to analyze the gender of faces in the image, location already tells you a lot. This is so fun. When you have a group of people, I don't know if you noticed that, the gender distribution in terms of location. Anyway, before I say it, take a guess. Closer to the center of the photos, do you see more female or do you see more male? Take a guess. Actually, in this case, you're probably going to see that you see female more closer to the center of the picture, and then the male tend to be on the 2 sides flanking the female. It's just kind of social phenomena, human nature or not, I don't know. But statistically, you can show that. Therefore, with that kind of a priori information, we're able to analyze the gender even before we look at image pixels. Of course, if you look at appearance together, you get better performance. This one I thought was an interesting example to show. This one goes a bit deeper. It's not difficult, not easy to see the cursor, right? if you have a picture of two persons of different, you can see the age is different between two of them. If I ask you who is Lisa, who is Mildred, can you guess? You have never met them before. Okay, and this one definitely requires a lot more social context. In US, if I ask the same question, most people will recognize. Because at least in the United States, the names of, the popularity of names, first name, over time goes up and down. Certain age, generation, they all, Lisa is very common, right? Mildred tends to be more popular in the older times. So therefore, in this picture, if I ask the question, who's Lisa, who's Mildred, you can say the elder lady is Mildred, and the younger one is Lisa, even though you've never met any of them. Okay? Good. Okay, so I can go on with this, but all of this to show you that really AI is more than just deep learning. I know later at the panel we're going to have a little bit more debate about that, but it's okay, right? To me, AI has so much advanced in the last 10, 15 years because of computation, because of data, but also because the researchers are getting better and better at utilizing contextual information. Okay, maybe before I go and talk about AI Singapore, I want to show you just one more example, right? Look at this picture, you can say, wow, there's a lot happening here. Look at the sports, right? Someone riding on a horse. What kind of sport is this? Can you tell? I know how you call this. I call it polo, but is it? Okay, good, good. At least we're consistent in that. Okay, and you can also see that it's kind of outdoor kind of a structure of the ground plan with background and some foreground salient object. All these analysis that we just did by looking at the pictures ourselves, that's exactly what we want to teach the algorithm to do. And this is the algorithm we came up with. This one is about 5 years old. We have all these different pieces of algorithm all come together and then assisting each other to do the more holistic analytics of that image. Truth be told is that really because you know there's a rider on the horse, that actually reinforce your certainty that this is polo, right? Likewise, knowing that there's a ball on the ground, it reinforces your algorithm think that I should be looking for something that's going to hit the ball, right? All of this all come together in terms of analyzing the image to tell you what you just said already as a human being looking at the image. And that's what we came up with, as I said, maybe 5 years ago, as an algorithm, very, very holistic analytics of the image. So, okay, so maybe with that, maybe take a quick pause, see if any comments or questions people want to throw out. Yeah, all good, nothing controversial, and all of you agree with me that other than computation and more data, contextual information is becoming interesting. Thank you. Anyone online? No? No? Yes. I don't know anyone online. I don't know how we do this. Okay, so let me just jump. So for the remaining 5 minutes-ish, how much time do I have really left?
I think, yes, you have 5 minutes, around 5 minutes.
Okay, so let me try, right? So again, my point is not to give you all the details about either contextual information or AI Singapore. Really is to kind of open this up so that we can have more engaging conversation later. So AI Singapore, of which I have the pleasure and really the honor to serve as chief scientist, is a national level program, really started by Singapore government from 2017. Time flies. And it's gone through phase 1, phase 2, we're in phase 3 now. It's a lot of investment from the government, and we, as part of the AI Singapore office, are really trying to do our best to deliver what we're supposed to. I don't have to go to all of these high-level statements, rather than just saying that under AI Singapore, we have these 4 major streams of efforts. First one is very, very basic science research. Second is what we call technology, grand challenges that I'm going to tell you more about. Third one is innovation. We were just talking about 100E. That'll be under this AI Singapore innovation pillar. The last one, even though the more recent, but not the least one, is AI governance. Actually, later, I think during the panel, we should have a bit more conversation about AI governance, ethics, and all of that. So these are the 3 pillars of AI Singapore. Of course, our aim is to really make sure that as a program office, we allocate resources, we sponsor research, we launch grand challenges to deliver what we're supposed to do for AI for Singapore. Okay, so on the research side, I thought I'd just highlight a few things. Really, one is all about talent. If you think about what we as Singapore, as a nation, are able to accomplish already today, it cannot be done without the talents we have here in Singapore. Look at these numbers. These are more for academic, the professors, right? For us, in terms of measure our success, right? Publications, citations are usually numbers that we count on. More important is this number called FWCI. Anyway, Yaping, you know what that means, right? Right. That shows how successful our publications are actually being referenced, right? Meaning, if you write a paper no one even bother, what's the use, right? If you write a paper that many people refer to your paper, that means you're good. So FWCI 1 means you're just average. In this case, Singapore as a nation, FWCI is as high as 2.08. Means that any paper that comes out from AI in Singapore, is cited more than twice of the average. And Singapore is, in this case, the top of the world. And of course, that gives me even more pressure. So my job now is, of course, to ensure that Singapore continue to be in that leading position as far as we can perform everything we need to do for AI Singapore. One more thing I also want to mention. It's not just about the citation, right? If you look at productivity, Singapore produced about, let's see, just pick a number, right? Around here, right? 5,000 papers in that period, while if in comparison, United States produced 50,000, like 10 times more, right? But if you factor in per capita, right, Singapore is what? Population-wise, 1/50th of US, roughly speaking, right, give and take, right? But the internal publication is 1/10, right? That means Singapore is what? 5 times more productive than Americans in terms of producing papers. That's something to remember. Productivity, but also the impact of our work is number 1 in the world. Keep that in mind. Of course, let's just give you an example. This is one professor that AI Singapore was pleased to sponsor. Since then, he has not only increased his own productivity, he has also increased his impact. He works on counting. And maybe ask, okay, what does counting have anything to do with AI? Think of it this way, right? If you have, say, this is all about counting of solutions that satisfy a Boolean equation. Okay, all of you from triple E should know what a Boolean function is, right? If I ask you A and not A, how many solutions are there? 0, right? You cannot be A and not A, right? But if I ask you A and B or C, okay, you can do all the things together. Maybe 4 solutions, I don't know. Yeah, you can do it. But if I start asking you, right, A, not B, or C, and D, it goes very fast, right? So his research has a lot to do with counting the number of possible solutions. And it turns out that he's been highly ranked in this journal called Intelligent System. This is Subway. I say if you want to count how many passengers in the station, that kind of thing, who are carrying a bag or not carrying a bag, that kind of thing. So you can see counting actually has a lot to do with data science and machine learning. I understand many of you are students, so I thought I would just mention this. Over time, AI Singapore has been sponsoring PhD scholarships with very, very, I would say, attractive benefits in terms of compensation. But more importantly, of course, by working with AI Singapore as a fellowship recipient, you get to work with smart professors. You get to work with industry that will end up hiring you when you graduate. Okay, AI technology has to do with a few grand challenges that we run. I'm not going to go to all detail other than just showing you one grand challenge. This one, right? This one has to do with healthcare. How do you use artificial intelligence to track patients and thereby reducing the number of cases for this 3H? I'm not going to attempt to read those words. They are very difficult to pronounce. I'm just going to say high blood pressure, high blood sugar, and high cholesterol. That one is easy, right? I'm not going to attempt like hyperlipidemia, that kind of thing. But you know what I mean? So it turns out that these 3H problems are really what's plaguing Singapore for large population and loading on the healthcare system. So we're trying to see if you can use AI as a tool to change people's behaviors, ask them to monitor themselves more often so that we can reduce 3H by 20% in the next 5 years. That's the aim. And it turns out that we have already sponsored 3 teams, one of them from NTU, and all of these working with all the 3 healthcare systems in Singapore. This is a technology change that was just announced a few weeks ago. This one has to do with fake media. I guess many of you have heard about deep fake, or this online video showing whoever saying things that they have never said, right? So we were able to run a competition like that, and very happy to see that 3 teams were chosen as top winners and announced last week. Okay, maybe the last few slides, maybe the last pillar, if I say, this is AI innovation. 100E, to be exact, we have a lot of projects where we bring in the real world problems from the company and the talents, professors, researchers from the ecosystem, and try to make them work together. Every project is one experiment, and we're aiming, well, it's just an expression, 100 experiments as such. And during which we're going to train, we are training a lot of what we call AI engineers. And by now we have trained already close to 200 such of them. Okay, I was told that the web browser doesn't work, so I'm going to skip this one. Other to say that these are companies that after they have conducted these 100 experiments with AI Singapore, these are their testimonials showing, explaining to people the impact that AI Singapore has done for them and their company. This is not working. One of them happens to be HP. I was going to show the video from them utilizing face recognition, tracking of people as you move into the factories, so that during the COVID time they were able to see, or are you wearing face masks properly, or are you keeping your social distancing between people when you work in the factory clean room and all of that. Okay, Analytics, I don't know if you see yourself there, but it's too certain. Yeah, so Analytics is one of these companies that we work with during the 100E exercise. Okay, maybe one thing I want to point out is that AI Singapore is a lot more than just, doing advanced research. It's also a lot about educating general population in terms of awareness. Therefore, you can see that we go all the way from primary school, not so much the students themselves, but the teachers of the primary school, right, to educate them about AI. Secondary school, poly unis, and the working professional and trained professional. So for the whole spectrum, we try to bring up the awareness of AI and make sure that everyone in Singapore gets to know what they need to know about artificial intelligence. I'm not going to go to all the numbers, but just to show you that we have certainly by now created a lot of impact by bringing people's awareness to AI. It's not working. Okay, this is one thing I thought would be useful maybe for a later panel discussion also, right? One challenge that we have in AI Singapore is actually not so much about talents, students, professors. It's actually a lot about the customer that we serve. In many cases, we realize that they come in and ask similar questions without even knowing each other. In some cases, they come in and ask questions about AI while they are really asking questions about digitalization. This is a little bit hard for me to say, but it's true, right? When companies come in and all get excited about AI without any information digital, that's a long way to go, right? So we started with this effort called Index, AI Readiness Index. For every company to come in to work with us, they can analyze their own AI readiness. And then for different level of readiness, we can help them differently. Not to say we help them or not help them, but help them at different levels. And we come up with all these, how you call questionnaire indices that you as a company, by looking at your, pointer not working. Okay, yeah, talent, by looking at your readiness in terms of data, in terms of algorithms, in terms of infrastructure, then you know what level of readiness your company is with. Then we, AI Singapore, come in and help you probably at that right level. Okay, so I know I'm running out of time, so let me just conclude by saying this. One, AI is more than deep learning. I know later, a panel discussion, some of you are going to debate with me on this one, that's okay, right? AI is more than just about faster processing, running more data and just throw it at the neural network, right? AI really has a lot more to that we can explore. Today I'm just sharing with one angle with you, which we call contextual information. Okay, there may be other angles that we should explore. And for all of the students, aspiring students, do explore all those things. Don't think of everything as the neural network. Okay. The second point I wanted to make really in summary is that AI Singapore has been around. We're all here to help you. As chief scientist, in a way, it's my job, it's my passion also to help you not only advancing your own technologies, but also trying to translate your technology to the end customers. Okay, I just want to bring out this picture. Now take a look at all the pictures, all the individual elements, and realize that they have nothing to do with, individually they have nothing to do with the kitchen, but all together you can see how that creates the illusion of a kitchen. And my last picture is this, right? This is something that, for those of us working on images, actually Professor Tanya Ping also work on images, right? This is our holy grail, right? If I ask you, if you have an algorithm that can look at this image and tell me, maybe start with how many people are there in the picture? Remember, some of these individuals probably don't even have 2 by 2 or more than 4 pixels covering their face, right? And then what did they just do? Did they just finish it looks like they just finished some event, right? They were all happy taking picture. Apparently it was a happy event, not like something everyone was dragged down, right? And then they were just all pleased that the outcome of whatever that event was useful, right? So when does AI really come to the level of analyzing the image and come up with all the statements that I just made as a human viewer? That, I think, to me, is the day that AI holy grail has been reached. So I'll end there, and happy to entertain any questions, or we can go into the panel discussion. Thank you.
Thank you, Professor Chen, for the plenary speech. And please take a seat on the stage, and let's move on to the panel discussion. And now, I would like to invite our panelists on stage. Let's put our hands together and welcome Dr. Yao Wei Yun, the Department Head of Robotics and Autonomous System Institute for Infocom Research of A*STAR. And Dr. Chen Tsuhan, the Principal Investigator of A*STAR Center for Frontier AI Research. And Mr. Arnold Doré, the Chief Executive Officer of Terra AI. And Mr. Leonard Tan, the founder and CEO of AI Lytics. And our moderator, Mr. Andrew Sugong, the president of MLDA EEE. And now, I would like to hand over my time to Mr. Sugong for the panel discussion. Mr. Sugong, please.
Yes, test. Okay. So yeah, thanks, Inche. So yeah, first of all, I would like to welcome everyone here, both joining us physically in Lee Kong Chian LT and also those who join us virtually in the Zoom webinar session. So before we start, I will announce the rules for the Q&A session first. So for those who are joining us virtually, please drop your question on the Zoom webinar Q&A section, and we will choose some of your questions later at the end of the panel discussion to answer some of your questions. And for those who are joining us physically here, there will be a dedicated Q&A session as well after the panel discussion. So yeah, the topic of today's panel discussion is Next Revolution in AI, Future Innovations, where we will talk about some of the future ideas on future ideas of AI. And joining us here are outstanding panelists from the various sectors of the industry, such as the research institutes, the government, and also the startup sectors as well. So before we start, I would like to give the chance to each of the panelists here to intro themselves, give a short introduction on what organization do they represent and what do they do. So I think we can start with Dr. Chen Tsuhan, and we can go through one round. Yes. So
sure. Hi, good evening, everyone. So my name is Cheston, and I'm a basic researcher as opposed to someone who does more applied research. So in my current role, I've graduated from my PhD about 10 years now. So I lead a small research group at A*STAR. And this is a new research group that we deal with really basic research, and we call it the Center for Frontier AI Research. So of course we are actively hiring. I'd be happy to talk to any of you interested in doing basic research. Thank you.
Yeah, good evening, everyone. I'm Yao Yin from the Institute for Inform Research, ASTA. I'm really honored to be here today on this event. For myself, I look after the Robotics and Autonomous System Department. Currently, my research is on robotics, looking into how robots can be intelligent, right? How robots are be able to be useful in a human life. Another area will be neuromorphic computing, where the focus is how can we achieve ultra-low power computation, something that can be useful, right, for example, in robotics area as well as a human life. Right. Thank you.
Hi guys, my name is Arnold. I'm from Terra AI. My company does, it tries to simplify AI. Most of the time AI can be very complicated, maybe for researchers, but we try to simplify it to the point that even non-programmers and pretty much anyone can get started in AI.
Hi everyone, my name is Leonard, and my team and I are a computer vision-based company in the construction industry, helping the main contractors to improve their safety and productivity. We are actually a spin-off from the very successful 100E program. Highly recommend it. I think it's really, really good, whatever they are doing there in AI Singapore or across the board. But yeah, happy to be here.
Nice. Okay. Thank you everyone for your introduction. So yeah, I think we can go straight to the panel discussion. So as we're joined here by speakers from various industries, right, I think we can start with the basic question on what's your opinion on the current state of AI development or AI research based on your expertise in your industry. And like, just to give a context, like currently we are, I would say, almost out of the COVID pandemic phase, and we're moving to the endemic phase. So yeah, we're going to the reopening phase where like, yeah, people are going out again and like they are spending less time on their screen. So yeah, anyone can just jump in and say their opinions. Anyone wants to?
If I just get this started and I'll wait for my parents to shoot me down.
Yes.
That would be fun, right? Okay.
Yeah, that will be fine.
So I'd like to start by saying that really AI started many, many years ago. And at that time, it was actually very, very general. Nice. Right? And as the new wave of AI has become more task specific. And all, of course, thanks to the advancement in deep learning, what's called. Right? I always say this joke that I share with people. For me, if you look at deep learning as of today, it's many, many layers of neurons, neural network. I say, yes, it's deep, okay, in that sense. But is it learning? I don't know, right? So I say it's deep neural network, it's deep learning, I don't know. Right? What's interesting going forward, I want to say that indeed it's going back to the more general AI, or okay, to the, they say general artificial intelligence or artificial general intelligence, all the same thing, right? So I actually would encourage people to start thinking more than just neural network, more than deep neural network, more than convolutional neural network, and start thinking about other things. So that would be my take. Of course, I wait to be corrected.
Yeah, if I may jump in, actually, maybe this is not so fun, but I agree very much with Tsuhan. I actually come from the computer vision background like Tsuhan does. And I agree very much that a lot of has been lost over the past 10 years. So the deep learning revolution, of course, came about 10 years ago, right, which is the ImageNet challenge. And I feel that a lot of things have been lost. I mean, examples that Tsuhan gave were very interesting. This was from 2008, 2009. A lot of the problems were lost because people focus on certain problems that are solvable by deep learning. You know the saying, if all you have is a hammer, everything looks like a nail. So deep learning being the technique of the decade or technique of the day drives people towards certain problems. And I think other problems that are less addressable have been neglected. So I'm a bit pessimistic about that. At the same time, from the industry point of view, I think I'm very optimistic. A lot of the problems have really starting to see real world applications. So I'm both pessimistic and optimistic.
Thank you, Chester. Yeah, I can just chime in on this. As a commercial company, I do agree, with what you guys mentioned on the state of AI research in the field, the advancements there, and sometimes, at least in my point of view, what is happening now is that the AI research, there's a lot of open source tools, which is great. A lot of it is shared, a lot of it is public compared to some other fields. But that also gave rise to a couple of other motivations when certain research is being done, be it for monetary gains, a bit more flashy, reusing of slightly almost the same thing but in newer, more flashy terms. And sometimes they are just thinking about the monetization aspect. I mean, it's not for everyone, but there are some papers that I've seen they are basically saying the same thing over and over again. While I also do believe that a lot of the industry can still benefit from a lot of the AI work that has been done in the past, like it might even be 10 years ago, the state of the world now and companies can still benefit a lot from the work that was done so long ago. So I do believe, even though the research is a bit, I would say, not stagnant, but slowing down in terms of the progress, the industry ideally should catch up with a lot of the advancements that we've made over the years as well.
Yeah, I think maybe as I can chime in as well, definitely I agree that basically there are many things else we can do. But we also want to take a look at in the area of, because I'm more from robotics, right? From the area of robotics part, we are looking at some peculiarity, right? For example, today we look at advancement in computer vision. There's a lot of examples given. The use of deep learning, unfortunately, consumes a lot of power. GPT-3, right, for example, I was told that when they train the GPT-3, there's actually some error. But they do not want to retrain again, right? Because the training itself cost them about $100,000. But you can think of it, can my robot, with the amount of power it has in the robot itself, how do they survive, right? I mean, human, for example, our brain consumes 60 watts. How much battery can I carry in the robot itself? So to me, the challenge is that if I want to have the computation, the intelligence in the robot itself, then the advancement today in deep learning, right, is not enough. Because I have to send all the data back to somewhere, right? And that alone also consumes power, right? And can I have a general capability in the robot itself that can be able to react immediately, right? For example, we say, okay, I have a robot that do patrolling. Suddenly something's wrong, right? How do you know something's wrong? Then how do you put all this intelligence to the robot that is enough for it to carry in the robot itself rather than outside? So to me, one of the challenges currently that's not solved is how do you come up with a good intelligence, but yet it's also ultra low power. So there's one the intelligence part I think that's missing. Yeah, thanks.
Just to follow up on that comment there, I think that's actually pretty insightful, true, because there is a huge gap right now between the state of the art and really what's practicable in the industry, what's affordable in the industry. GPT, by the way, GPT-3 didn't take $100,000, it took $21 million to actually train. So it's very expensive to train these models. DALL-E, for example, DALL-E 2, which can actually, you type in the sentence and it actually produces some kind of image which, let's say you say a fat elephant with a cow, and then, it'll produce an image like that, right? It's incredible what it can do. But it takes a lot to train. So a lot of the research funding, a lot of the brains go into building these big models. I'm not saying that's wrong, but I'm saying that maybe that's not the best way to actually spend money from a funding point of view. And perhaps, as my fellow panelists said, that these models are very, very big. They are, several billions of parameters, and they won't always fit into one, even GPU. So maybe there could be other methods to do the same thing. I mean, neural networks are now the most popular method to do anything, but there might be other ways to do something perhaps less accurately, but more cheaply. For example, to take an analogy, right? XGBoost, which is a very simple technique, I mean, relatively speaking, but you can use it to perhaps work on tabular data and so on, which a lot of companies would find useful. You don't need deep learning for that kind of stuff and so on, right? Is there comparable techniques? Are comparable techniques being developed for either, maybe contextual visual learning or perhaps even in NLP, which are cheaper to train rather than $21 million? And perhaps that makes it more accessible for companies to experiment with and play around with without having to resort to a large budget before they can actually see some kind of innovation. So I think that's the main thing for me.
I see. Yes. Thank you for your insightful information. So yeah, I think just to summarize, I think there are several main points that the panelists have conveyed. So yeah, firstly, I think from the research side, I think we are going towards the more general AI, where instead of AI that focuses on just a certain specific domain, but more on like AI that can like do several or like a lot of different tasks. So like so that they can be more of like a human, where they can like do a lot of different tasks. And secondly, I think from the startup sector, I kind of listened that yeah, I think there is some gap between going from research to going to the production. Like yeah, both on the cost, on the software, and yeah, there are many obstacles converting the models that have been created by the researchers on AI to the production into the devices. So yeah, I think that's the two different problems from two different sides of AI industry. One from the researchers and also one from the deployment or like the industry side where they deploy the AI models as well. Yeah, they deploy the AI models. So yeah, I think now let's talk about the breakthroughs that have happened in the AI. So like actually in the past 40 years, there are a lot of significant breakthroughs that have happened, yeah, such as like the CNN, the Convolutional Neural Network. It was founded in 1998 during the AI winter that time. So yeah, it was not popular that time. It was created by Dr. Yann LeCun, and which give way to actually most of the current state-of-the-art computer vision models that we use today. And for NLP, we have the Transformer, which was founded quite recently in around 2017. And this gave way to the rise of BERT. So this BERT model is a unified model that can do a lot of different tasks for NLP, yeah, just using this single model. So yeah, in the future, what do you think is the next breakthrough in AI that will push the limit of what AI can do? And what breakthroughs do you most look forward to if you would like to yeah, see? I think anyone can just join or start the discussion.
I wouldn't call it a breakthrough, but it's true that actually not just in AI, but data science in general, right? We have, as researchers, swum back and forth between more model-based approach versus more data-based approach, right? And for AI machine learning specifically, the last, 10 years, really because of people like Yann LeCun, Jeff Hinton, and all of that, is taken a more data-driven approach, right? No matter how challenging the problem is, just keep throwing data at this neural net, it's going to pick up with a lot of machine powers and all of that, right? And indeed, because of that, people have been kind of have forgotten a little bit about where AI started with, right? Very, very strict model-based approach, almost a kind of a rule-based approach that's extreme, right? I think going forward, what's needed is a nice hybrid between the data-driven approach and the model-based approach so that the best of the two worlds can be brought together. I think we have, well, I can say, I think deep neural network is a good time for the last 10 years. But going forward, I do want to see, again, not breakthrough. It's more like going back to the roots, right? To think about more model-based or even rule-based approach and try to blend all this together.
Yeah, I think for me, definitely, I think the two things I'm most excited about, yeah, I wouldn't really call them breakthroughs because they exist today, but I would like to see much better versions of them and in more effective versions. One is definitely GANs, right? Generation of, you can imagine if we can generate, really realistic data sets of whatever scenarios that we want, dangerous scenarios, so on and so forth. The amount of time now that AI companies or researchers spend, maybe data collection and all these can be rechanneled and refocused to a lot of other areas. So I think GAN would really help to accelerate a lot of other aspects of AI research and development as well. The second one is a bit more kind of commercial based, but I'm really excited about federated learning. A lot of the times now, one of the struggles is that, yeah, when you start an AI project or AI research with a company, you do a lot of things, and then once everything is done, then the shop closes. And then we know who looks after the maintenance, and there's a lot of issues with the maintenance and upkeeping of some of these models. So federated learning, I think, is a big one. Really looking forward to what's going to happen in that space.
I think coming back to my example, we mentioned that if we want to have AI that really being useful, we want to realize it in the robots, then the question of ultra low power type of model will be very useful. For that, perhaps maybe what we are doing today might not be the right direction to achieve ultra low power. So how do we do that? So there are people who try to see what can we learn from biology. So potential areas that we can look into is spiking neural network, for example. Right? So spiking neural network, we look into two components. Right? One is the algorithm itself, and one is the hardware to model or to compute the spiking network. Right? Because it's event-driven and it's temporal. On the conventional von Neumann will be very challenging. So there are efforts to try to solve this, and we realize that one of the part why today's computation is so power hungry is because of the data. Right? You need to move the data, and that's where the energy is being consumed. Right? So how do we do that? So we look into the hardware aspect, and in terms of hardware aspect, potential areas that maybe some people may not agree. Right? NVIDIA may not agree. Will be, can you look into chip that's being built in 3D form? Right? So that you want to reduce as much as possible the movement of the data. So the area of spiking neural network in terms of algorithm, in terms of how do you design this into hardware, I would think that these are one areas that potentially would be useful, emerging in order to resolve the power efficiency problem. Thank you.
So, I mean, carrying on this note about low power, I'd like to think about less data or little data, low data. So, I mean, so we talked about Yann LeCun. So the other two godfathers of deep learning, one is Joshua Bengio, right? And of course, it's Jeff Hinton. So there's an interesting quote from Joshua Bengio, 2019. And basically, I mean, don't quote me on the exact words, but basically saying that the deep learning systems at that time, the best deep learning systems are not even as smart as a 5-year-old child, right? And you can search the quote online. And I happen to have a 5-year-old child and a 2-year-old child, and I can tell you they're smarter than what you would think, right? Of course, they don't have adult level sort of common sense knowledge about the world, but it's amazing how much they learn, right? It's like every single day they learn 2 or 3 new words, just automatically. You don't have to teach them explicitly, but just pick it up just by absorbing the language around them, right? So I think this is very interesting direction. And like many of you, my background as an undergraduate was in computer science, but for my PhD training, I actually turned to neuroscience and psychology. And I'm hoping that this human-inspired AI or biologically inspired AI will sort of be the source for the next breakthrough in AI, because I think that's a very rich source of inspiration that has been not so much tapped today. Thank you.
One more point to that. All this year we've been talking about big data, right? And of course there's a reason, right? Big data and neural networks all come hand in hand. I like a recent article written by Andrew Ng. He also has an interesting way of saying obvious thing. He says, small is the new big, right? So going forward, a new frontier of AI is to see how we can still build all these models with very, very little data. So I'm just going to share that. So a little bit to what Jason was saying, right? I mean, human brains really doesn't need a lot of training data, and we turn out to be okay, right? I mean, not all of us are super smart, but in terms of analyzing images, we are still much better than algorithms, right? So what is a small as a new big? I think that's a new frontier to look at.
Yeah, for me, I think the fascinating thing about the recent development of transformers, for example, is how a fairly simple mechanism, along with a lot of textual data, can result in something that behaves, remarkably like human intelligence, right? Of course, it's not. But what this tells me also is that there's this wonderful first of all, that textual data probably contains a lot more information than we normally think it does, right? That, in other words, from textual data itself, we can actually bootstrap a lot of those innate things that children have, like, language acquisition and so on, even with fairly simple mechanisms like attention. So what I would like to see really for breakthroughs is how can this attention mechanism be really understood, really quantified better, and perhaps applied to other things where contextual extraction is more important, right? So that's for me.
I see. Yes. So yeah, some interesting ideas or points from the panelists here. So yeah, firstly, I think there's the federated learning by Mr. Leonard. So yeah, I think in the future, privacy is getting more and more important in the AI industry. So I think if we can like, I would say train from the data, but also preserve the privacy at the same time, then I think it will be a great breakthrough. And I think the next one will be the biologically AI that mimics the biologic of the human. That I think, yeah, I think spiking neural network is something that's very interesting as well, because yeah, if we can do it, why can't computer do it the same way as we do? So that, yeah, because like I think now the computers, the transistor size are also, I would say, reach the limit. I would say it's already almost 1 nanometer. Like beyond, like lower than this, it means it will the quantum effects will actually dominate the thing. So yeah, I think if we can have like a spiking neural network computer, which is much more efficient than the current transistor-based computer, then I think it may, I would say, give more computing power, which means AI can be trained faster, which means there will be faster development of AI. So yeah, which in turn may also produce AI that only uses very little power as well. So yeah, I think it's I think we are not that near for now, but yeah, I think it will be interesting to see that in the future as well. And yeah, the third one is by Mr. Arnold Dore. So yeah, sorry, Mr. Arnold Dore, can you repeat your points just now? I didn't remember.
Sorry?
What's your breakthrough that you would like to see just now?
Okay, so what I was saying was that the interesting trend in the last, let's say, I think about six months to a year or plus, is this thing called transformers.
Nice.
So they are basically very much like your normal neural networks, but the way they process the data is a bit different. It started off with a paper by Google, I think in 2017, called Attention is All You Need. And a lot of people have used that initially for natural language processing, right? When they first started off, the work that came out of that was not really very compelling, not very spectacular. But what they did was they made the network bigger and bigger, and of course, much more expensive to train. And in the latest version, it's called GPT-3, it's massive. And the capabilities of something like this is also remarkable, right? So what struck me, honestly, was not so much the performance of the model itself. What struck me was that a fairly simple mechanism, which is attention, with textual data could yield something that where you can ask it a question and it gives you, a very reasonable, realistic answer. If you can have, you can do things like sentence completion as well, very well. Okay, as far as I understand it, GPT-3 was trained to actually forecast or predict the next word in a sentence. Let's say you say, I am a, then predict the next sentence, right? So by training the network to do that and using a mechanism called attention, they managed to actually achieve really remarkable performance, which can understand context as well. So that really is strange. So what struck me was that its text alone with a simple mechanism can actually give you really complicated behaviors. And I'd like to see something like that being analyzed a bit more, right? The interplay between model and data, specifically with attention.
Yes, yeah. So I think attention was one of the breakthroughs that was founded by the transformer. Yeah, that allows like the model to learn which part of for NLP, which part of the sentence or which part of the data that they should focus on, and yeah, should they focus and know where's the answer. So yeah, thanks for all of your insightful answers. So yeah, actually one of the, I would say, breakthroughs that I would like to see actually have been mentioned in the first question answer, which is AGI, Artificial General Intelligence. So yeah, I think it will be really great if we can like replace human on some of the mundane tasks, just like what Tesla robot was tasked to do. Like they can do some of the mundane tasks so that we humans don't need to do what we don't want to do. So yeah, but there is a lot of debate ongoing about this robot, like regarding its ethics and yeah, many other topics. So yeah, what's your opinion on AGI in general? Like, do you think is it going to benefit humanity in general, and is it something that the AI community is actually striving for in the future? Yes, anyone can just join.
Yeah, maybe let me jump in. So I'm a fan of AGI. My work is towards that direction, but I think we should be careful what we're hoping for. I'm thinking about the image that Tsuhan showed, right, about the family, two adults, two children. We assume, and we're probably correct, that they are husband and wife with two children. Because of experience, and 99% of the time will probably be correct, but these are assumptions. We don't know for sure that it's true, right? So it could very well be the case that, it could be the mother and two children, and her brother is there, not her husband, helping to look after the children. Could very well be the case, right? So when we talk about human level intelligence or AGI, you have to be careful in that humans are not always correct, right? They're correct a lot of the times, we're not always perfect. And if we're looking at AGI, we have to be prepared for the cases where it may fail also, right? So as opposed to another direction for AI, which is one very accurate, very high performance AI, I think that's something that's quite different, and it's a very admirable goal as well, but that's not exactly AGI.
Yeah, I fully agree with that. I think just to tag on to that, the tools that we have at the moment just to measure, narrow AI models is also not really sufficient. And imagine, something like an AGI or GPT-3 or DALI, how do we measure it, right? We are limited kind of intellect, like I would say contextual by knowledge, and we are building these systems that we don't even know or have a good metric to understand what they are doing. So the problem will only be exacerbated, right? All these assumptions and all this, when we move towards this AGI, they're going to be much worse than the already biased things that we are seeing seeping through the narrow AI models. So my kind of thought on AGI is that even though we got a glimpse with GPT-3 and all these kind of things, I think the world can still benefit a lot from narrow AI for sure. But general AI can be useful in, I think, certain key aspects, for example, dangerous works and things like that. Certain key industries or tasks where we can train some form of, I wouldn't say AGI, maybe somewhere in between, to really help out and assist with this task to bring more societal kind of benefits than trying to strive for one supreme intellectual kind of computer or being.
Okay, so
go ahead.
Sorry. Since I mentioned this AGI or GAI now, doesn't matter. It really depends on what we made of it, right? To me, AGI could mean two totally different things, and actually some of the discussion earlier also reflected that. AGI could mean rather than just doing a simple task such as face recognition, we ought to broaden it out to do to work on speech, to work on text, to work on sense making, to work on more generally defined tasks. For that, I'm all supportive. As I mentioned, when AI was started, it was like that, right? It's only because of convolutional neural network that's already overtaken this, so that image recognition become the core of AI. But no, image recognition is only a small part of AI. That definition, I really want to see AGI become the future of our research. If we think of AGI, I start saying that we're going to create a machine that's more intelligent than human, then I get concerned, as many of you also reflected, right? To me, AI is never meant to replace humanity, even though everyone talk about singularity and all this and all that, right? I think what's important for us to realize that as we make AI more and more general, we also need to pay more and more attention to what we use AI for. In fact, to muse upon what Chester mentioned, right? Indeed, right? As you make algorithm more and more intelligent, such as using contextual information I mentioned earlier, right? Any of you in Triple U should know that when I say contextual information in statistics, it's referred to as a priori, or prior probabilities, right? So it's all those probabilities that make us make the decision. And Justin, you're absolutely right. We can also make wrong decision when a priori mismatch with the real data. I'm going to push this statement even further. A priori, in some contexts, could mean bias too. In fact, in statistics, we use bias for all the good reasons, but in the more social situation, bias could be something very, very bad, right? So maybe just to conclude, I would say AGI is definitely something we all should be looking out for. We just need to know what we mean by that. If it's using AI to broaden its views so that it's now focused on one test but multiple, that's a good thing, and let's keep pushing on that. If you think about AI becoming more intelligent than human being, then let's be careful what we are really trying to accomplish. In fact, I actually think it's already time for us to think about, as we develop AI, how do we make sure it's AI for good? I think some of you are probably, I think it's time for us, the AI researchers, to start thinking about, are we doing all the good things, or are we just throwing out these powerful tools and let it do whatever it does or whatever it's not supposed to do? So later, I definitely want to talk more about this AI for good if any of our panelists is interested as well, or if the audience is interested.
Yeah, just to follow up, I don't know. I'm more on the optimist for AI and AGI as well. I think that AI will always be for humans something that enhances us, something that makes us better, something that makes us able to achieve things that we couldn't before. It can be something that helps us to design better cars, better spaceships, better rockets. It might be something that helps us to design a fusion technology, for example, right? Which we can't do because we can't imagine things in very high dimensions, but AI can. We can't work in very high dimensions, which might be necessary to do all these really complicated design work for engineering. So I think that AI will probably take the human race into a whole new dimension. And I think sometimes that the fears about AI becoming more intelligent than human beings, it's reasonable, but I think that's only if it has got intent. But most of the stuff we do doesn't have intent. It doesn't have a reason to do things, right? Apart from the reason that we give it. I think the most dangerous thing about AI doesn't have to be when we have AGI. It's now, all right? It's about human beings using AI for bad, AI for bad, right? AI for control, for example, right? Maybe you have a repressive government, for example, that wants to control its citizens. Or perhaps you want to have a rogue company that wants to distort the market, financial markets, for example. You can have AI to design missiles which can kill people or weapons, right? So any tool can be used for good or bad, but really it's the wielder, the one that holds the AI that controls it. And that really is what worries me about the current trend about large models, because those very large models can only be trained by companies with a lot of cash, a lot of compute power, for example. That's a handful of companies around the world, right? So what we don't want to do is to have this very powerful technology being controlled by one or two companies or three or four companies around the world, right? We want to make it more democratized. And that's why I feel that there needs to be more research into non-connectionist methods which require lower power computations, or perhaps even a way to, I think it's hard to actually make better hardware, but I think that part is hard. It will always be perhaps expensive because we are almost reaching the limits of what current hardware can do.
I think for me, I want to add that yes, generally, to me, I think all the panelist members have mentioned, it's useful to have a AGI. But if you look at in terms of the usefulness of it, right, where can it be applied? And of course, from robotics point of view, if you want to have a robot that can serve many functions, then this is very useful. Let's take example, right? Today, a lot of people worry about sustainability, global warming, all this. And as simple as, all of us use computers, right? Have mobile phones and many others. When you throw it away, right, how do you treat the waste? So electronic waste. You things, probably a plastic bottle or these things, and throw away. Who do the recycling, right? You will notice it end up in somewhere. Either you incinerate it or you you dumb it, all these things. But if you want to get someone human to do it, nobody want to do the job, right? But you want to get robots to do it today, it's very challenging, right? How do you know which items can be recycled or not? There are so many variations, right? And you know that each variety, to get all the data to train it is very challenging. Secondly, how do you do all the manipulation to unscrew all the items and then pick it up? Well, this can be, example for the car, how do you uninstall all the cars and then separate items so that you can recycle? This alone is a very challenging task today that no robots can do it. And why no robots can do it is partly because of the actuation system, right? Robots need to deal with the physical world, and secondly, the intelligence, right? Can an AGI do that in a way that we don't consume a huge amount of power, right? Otherwise, you save some part on accessibility, then you burn another part of the world, right? So the question is, can we realize efficient AGI that can do that? Or if we want, can we sacrifice the AGI part so that the robot can do something that's useful, that's immediate, and something that's urgent for human before, our 1.5 degrees cannot be, undone, right? So these are challenges that I hope, all of you can, as a student, can take into it. And how do we realize an intelligent system that will allow robots to do multitask and hence, hopefully, do something that's beneficial for human now as well as in future generation. Thanks.
Yeah, sorry, just to add on, since we're a topic of AI for good, I think earlier this week, Facebook or Meta, they released the open version of GPT. They call OPT, right? So I think this is, amazing news because Facebook is generally more closed than Google, and yet they released this very massive, model. It's the same size as GPT-3 intentionally, and it's completely open, right? So I'm hoping this is maybe a first step in a race towards openness, race towards cleanness, race towards greenness among the major companies. Previous to this, it's been race towards closeness, race towards larger, race towards bigger data, and hoping the race has turned in a certain direction towards the positive direction. I'm hoping this is her first step.
I see. Oh yeah, yes. So thank you for your answers. So yeah, I think I have seen a consensus on the panelists that I think having an AGI is very, very useful, especially when the AGI can do a lot of different tasks. But just that we shouldn't, AGI may be detrimental for humanity if it gets smarter than human, or if it's doing something that is not trained to do. So I think having an AGI that's maybe I would say limited to mundane tasks or simple tasks, but a lot of different tasks, I think it will be useful in humanity. And another point is on the AI shouldn't be controlled by just a few, I would say, rich people or rich companies. So I think, because AGI is something that's now is very far away. So I'm sure that, I think only the rich people will be able to achieve that. The earliest, So I think in the future there is going to be some work that needs to be done on the, I would say, AI for all or AI for good, so that it benefits the society as a general. So so moving on to the next question. Currently there are new exciting ideas and concepts that is floating around, especially due to COVID, like metaverse and also the blockchain, especially the crypto. Blockchain is the underlying concept of crypto. And I think, in my opinion, those two concepts actually kind of have some benefits and some pros for the society in general. And it's the same as AI as well. It's very useful as well. So do you think AI can complement those new ideas and evolve into something bigger? And do you think AI can work together and produce something that's even bigger and benefit the society even more?
Yeah, I think I can start with this. So definitely, I'm very interested and involved with this Web3, phase that we are in. But AI can play across the entire chain, right? If you think about the hardware and the infrastructure required to run a metaverse, AI ops is the first thing that can be done. I think to efficiently leverage on the data that is being used, or even in the decentralized manner of a metaverse, and all the way up to the interactive content creation, immersiveness of a metaverse. A lot of AI is required to be able to generate a lot of this content, avatars, whatever you need in this digital world. So huge part, I would say, AI can play in the metaverse and blockchains, even to developing better smart contracts, for sure. We are starting to see some of it already. I think what Coinbase mentioned for what they're building at Decentraland with their AI ops is really quite interesting. I suggest you all can take a look and read that article. But definitely, I think AI will always have a role to play in almost all aspects of tech, whatever it might be.
Anyone else interested in taking the question?
I guess I can say something. I mean, I don't know much about blockchain, about metaverse, but I would say that, I think today's news, it wasn't Bitcoin, but one of the cryptocurrencies just really tanked, right? It dropped 95% of its value. So be very careful with cryptocurrencies. At the same time, AI is amazing, right? Very simple ideas can be very impactful. If you think about some of the revolutions in AI, like ResNets, it's a very simple idea to pass the residual instead of the actual value, right? ResNets. Transformers, again, attention, very simple idea, like Arnold says. And yet it's revolutionized NLP and now computer vision. So I think there's something out there, AI plus X, AI plus this and that. There's a lot of things to be done. And this being an AI research student conference, I think it's for you, the audience out there, to discover the next big thing.
I see. Yeah. Anyone would like to?
Can I comment on metaverse? Yeah, I have several ways to analyze this, but I'll start by saying that even the phrase metaverse itself really is not new. It was first officially coined by this writer for sci-fi novels called Neil Stephenson. I don't know any of you check out his books. Do check out this one called Snow Crash. It's the first time this phrase was coined, and this was 30 years ago. But anyway, so it's all about going to the virtual environment. Everyone's sitting in their own comfortable home, just send out these avatars and then interacting with each other. And of course, I'm not going to reveal the storyline, but it's very interesting. Do check it out. Second is to say that if you think about how Meta was touted as the future of Facebook, you have to think about what's behind this, right? A more cynical way to look at this is really that Mark Zuckerberg, maybe a few others, realized that Facebook has become the target of all of us to shoot at when it comes to fake news, misinformation, and all of that, right? So thereby they think by changing the name of the business of the company in the future, people will forget all the mistakes they make. Maybe. The third point to look at this is that now it really comes back to misinformation, disinformation is already going on online, right? Just ask ourselves this question. When it becomes, rather than Facebook, metaverse, where we all send our avatars, see each other, maybe the upper body only, right? Interacting with each other. Do you think this misinformation or fake news is going to be less or going to be more? What's cyberbullying going to be? How it's going to be defined in this virtual world now? We're going to send our avatars. I send a stronger one just to beat you up in the virtual space. Am I bullying you? Am I not? Right? I think it's a lot of interesting to be discussed going forward with this metaverse. Okay, something more positive, right? It's like I'm a naysayer for metaverse. What I think we ought to do, actually coming back to AI now, you start examining the impact of AI on social network for the last 20 years, including Facebook, right? Don't get me wrong. Right? Start thinking about how all these algorithms that curate the news content that you consume every day recommend books that you're supposed to buy from Amazon next time. Think about the effect it has done for all of us as humanity. It's done good things in promoting online commerce, but it's also done a lot of very bad things. Among them, what we call echo chamber. If AI is so good, I always ask the question, why is it that the whole world has become more divided now compared to 20 years ago? Is an internet supposed to be leveling the playing field so that everyone has a voice? And how come we have become so divided? If AI is so good, how come we have even more separation in society between the have and have not, right? If AI is so great, how come misinformation travels 6 times faster on the internet than was factual? And not just in terms of depth of number of people you reach, but in terms of that, it travels 20 times faster. It's pretty crazy out there, right? I don't want to say we have ourselves, AI researcher, to blame, but it's true. We have to be held responsible. All the recommendation system, collaborative filtering, whatnot, is creating all this effect already online. So going forward with Metaverse, I actually do want to inspire all the students in the room. Try to think about the power that you have in your hand called AI. And try to make this whole world a better place 20 years from now, rather than we sitting here 20 years and say, wow, what have we done to ourselves with all the recommendation systems, curating our news? What happened to Facebook, and now they have to change their name to hide their wrongdoing, right? So hopefully students have a brighter future to look forward to if you start thinking about the power you have in your hand. That's AI. Okay. I'm saying about AI for good, right? Okay.
Okay, I think one way I want to add, I think, yeah, when today, one of the key purpose of today's event is how do you attract students to, to look into AI. Yes, there's blockchain, metaverse and all this. And again, I would like to come back. What about AI and robotics, right? We mentioned about, Tesla, auto-driving cars. We mentioned just now about the sustainability, waste issues. I'm not sure, but you all are still young. I'm already old and my hair is white. When I'm old and getting older, right? How do we look into someone or robots that can look after me when I'm really, really old, right? I'm very sick, probably with dementia. Now, who's helping me to do my bathing, and guide me, remind me to take medication, or when I trip, somebody help me, right? I'm sure all of you have parents, right? Grandparents, who can do that physically, right? The virtual metaverse will not do that. You need some human and probably robots to do that, right? So how can robot do that, or robot to help human to take care of another human? So that's why I will say that please also look into how AI can help robots to be better, to help humanity. Thanks.
I see. Yeah, so I think it will be interesting if we can collaborate those. And yeah, for now, maybe there may be no clear, I would say, clear-cut answer on how to combine those new exciting ideas. So yeah, but then I think in the future, AI can help in a lot of different aspects of the metaverse and the blockchain, and many other ideas as well. For example, like the blockchain, because it's like I would say it's a public ledger. So, and it's, I would say, a graph base where like people can transfer their money to each other in like, and it's open to public. So since now like there are graph neural networks that is coming up. So yeah, I think in the future we can utilize those, utilize those to actually either like find fraud or some other criminalities that are utilizing the blockchain currently. So yeah, there are a lot of many possibilities ahead. So yeah, due to time constraints, we need to end off this panel discussion here. And yeah, there are a lot of different questions coming up in the Zoom webinar session here. So yeah, let's move on to the.
Any questions from the audience?
Can I ask a question,
Oh yeah. Sorry.
Okay, thank you, the panelists, for very interesting sharing. Okay, I just, when I was downstairs, I just cannot help to wonder, right? And this conference is the AI conference for students, run by students, and many for students who are interested in AI. And many of them just started their journey to learn, right, to explore. So now, of course, with your experience, with what you have achieved now, so what advice we will give to these students? They are at the beginning of the journey to explore the power, the potential, the challenges, the opportunities of AI, right? What do they need to do, right? With their authentic intelligence and with your a posteriori kind of advice so that they can achieve, make greater impact, maybe in 5 years or 10 years down the road. So if you look back, for example, 10 years ago or 20 years ago when you just started your journey, what would you do differently now in order for you to make an impact in this AI research or in AI field? I would love to hear your view on that. Thank you.
Well, guys, my advice is that if you want to learn AI, start by picking something that you enjoy doing. You know, pick a project. It could be in robotics, it could be in vision, it could be in NLP, it could be anything. It could be in recommended systems, it could be, in chatbots, for example, right? It could be anything that you want that you are interested in, right? And if you're not sure what you're interested in, then just pick anything that's close to your, perhaps to your skill set. For example, if you know a bit of math and you can do programming, for example, then go for perhaps doing machine vision, for example. Look around, scout around for projects that other people have done. That's a good place to start. A lot of the projects are on GitHub, they're open sourced. I think the really interesting projects that come with AI come with also things like where you're building things with your hands, not just programming. Right? So look at that too, right? Start somewhere. So starting somewhere is really important. And I think that when you build something, you get to understand what's involved, right? So start something first, get a result, right? I think a lot of you are MLD, I guess you're engineers as well, right? Right, engineers? Right, so engineers love to build stuff. Start by building something. And after you do that, then go back and try to learn the theory perhaps and see if that it really interests you or not, right? Join hackathons. That's a great place to learn. Find people who are like-minded, who are also interested in the same topic, and work on that. So that's my advice.
Yeah, maybe I can also step in. I still remember when after my university bachelor days, I started on masters. So that time, backprop is very popular. So no paper will be published if there's no backprop. So we look into backprop. Then after that, there's a AI winter, right? So I moved into robotics before the AI winter. So as a student, right, it's good to learn some of the useful technologies today. So AI is very useful, so learn how to use it. But then the next question you want to ask yourself is, are you among the many in the world? Right? If it is, how do you differentiate yourself? Right? If everybody is using AI, and yeah, you have an open source model, put data in, train, and then get the result, how do you differentiate yourself compared to others? And hence, we are looking at what makes you different from others. Will be how do you, for example, discover something different? Right? How do you, we look at the AI today, the model is so big that I'm sure NTU allow you to retrain another GPT-3, right? So maybe we ask Prof Tan here. But if it's not, then what makes it different? If you just use GPT-3, what makes you different from others? So that's where we want to encourage all of you to also look beyond just applying AI, but to how do you intelligently use AI into different areas? And hence, something that we look into the future, right? Something that potentially will be needed now, and more in the future will be, again, I want to highlight robotics. Right, it's growing. I just have a visitor from Italian Institute of Technology. They are one of the top institutions in robotics. They're saying that currently, for every single graduates in robotics area, there's at least 2 vacancies. Right, I think a few years before the COVID, we have visitors from US. They're saying that every single graduate in US on robotics area, there are at least 10 vacancies. Right, moving forward to that, I hope that all of you can look into this seriously. And how do you look into combining AI and robotics? Right? We are not looking into developing a robot that is from mechanical, but how do you put AI into robotics? And that's something that potentially would be useful in terms of career development, right? Also as a job opportunity that allow you to make yourself different from your other peers. Yep. Thank you.
My advice is also that when I started all this with all the open source research papers, conference papers, GitHub code, I challenge you guys to pick some projects, like what my panelists have mentioned already that you like. But when you read the research paper and when you look at the code, understand a few things. Understand first the motivation of the researcher who wrote that and when he developed the code. The second thing is understand where are the duct tapes. There are always duct tapes and assumptions, and they are very interesting. When you find this out, and you try to think of ways, to resolve these duct tapes, and then normally that will give birth to something new. You could even, create your own state-of-the-art model just by improving these duct tapes or some of the assumptions that they made, and it is very, very rewarding as well. So that nothing beats getting your hands dirty. And I would say when you go out into the industry, whether you want to stay on the research path or you want to become like a developer, in a more commercial company, I would say AI models is just one piece of the puzzle. You have the whole thing from data collection to deployment, right? So you got to also understand how you can wrap these AI models in other technologies, your platform, deploying it on the cloud, and so on and so forth, right? You don't have to go too much into detail, but if you have an understanding on how the whole AI pipeline will work, it will help you also gain more knowledge and insights on how to tweak or fine-tune your models.
Easy for me to say is that please come and join AI Singapore in its movement of maintaining Singapore's leadership in AI research. Please do join us in all forms. Seriously though, I do want to say that for the new generation, please do study very hard to know what AI is, to know how AI does it, and to know what AI is going to do. And make sure that you take control of that rather than that it consume you. I look at all of you, you remind me of what Mark Zuckerberg was when he dropped out of Harvard. And then he created Facebook. I'm pretty sure you can all be smarter than him and use your AI for good, for all the good purposes, so that you won't make the same mistake that he made in the last 20 years. So with that, thank you.
So for me, I have two pieces of advice, and I'll try to be short. So the first is for the subset of you guys who are more interested in academic research, publishing papers. I would really, really strongly advise you, especially if you're pursuing a PhD, to focus on quality. Right? Again, examples I gave, ResNets, transformers, GANs, very simple ideas, one person's PhD thesis. You don't need a whole team of people to make these happen. Rather than trying to get your 3 CVPR, 4 Neuritz papers out, go for quality. One single idea can make your entire career, right? So that's my advice for the subset of people working on basic research. So my other piece of advice is for everyone here, and echoing what Tsuhan and Wei Yun have talked about. You guys are engineers, I presume most of you are, or computer scientists. Also remember you're human beings, and when you're doing AI, also put on your human hat as well. Your sons and daughters, your siblings, your nieces, your nephews, put on this hat also, and remember that you're human beings with various interests. This is what differentiates you. Don't just be the next person who can use GitHub, download a code, and improve by 0.1% performance. There's really no value in that, right? I mean, it will get you a job, but that's not your true value in becoming an AI researcher. So please keep in mind, bringing your human head as well when doing your AI research. Thanks.
Okay, thanks for all the panelists for the answers. And yeah, due to time constraint, we can have just one more question from the audience. Is there anyone who would like to ask questions? Our usher will give the mic. Okay, yeah.
Hello.
Someone with the gray shirt.
Yeah, hi. I have a question for Dr.
Sorry, can you speak a bit louder?
Hi, can you hear me?
Okay.
Yeah, hi, I have a question for Prof Chen and Dr. Tan. You mentioned that in the past 10 years, a lot of the AI problems, important problems, have been lost.
Sorry, can you repeat the question?
Sorry, can you hear me?
Yeah, okay, that's much better.
All right. I have a question for Prof Chen and Dr. Tan. You mentioned that a lot of the important problems in AI have been lost in the past 10 years. Can you name one or two specific examples?
Yes.
Yeah, it's a good question. Let me try to find interesting specific examples. Because like I said, a lot of things has been dominated by deep learning, and naturally things with a lot of data, work well with deep learning. Of course, there is few shot learning also, or even zero shot learning, but this is a relatively new area coming up in the past 3 or 4 years. But a lot of stuff is still, larger the data, the better. But as Tsuhan mentioned, prior to that, people used to be a lot more cross-discipline. Talking about 20, 30 years ago, it was more cross-discipline, computer vision, natural language processing, robotics. The students were not so focused in one single thing, one single model, one single approach. Right? And I think there is a trend towards that. For example, at CVPR, there are workshops now, for example, in embodied AI, bringing all these things back together. So there is a slight trend moving back towards this older set of problems. But I think that the major thrust is still very deep learning centric, larger data, the better. Yeah. Tsuhan, perhaps you have good examples?
Yeah, I agree. And I also want to say it's not so much that these problems have been forgotten, right? Because end of the day, if you think about what we all engineers, computer scientists do, we're here to solve problems, right? Just don't lose sight of the problems. Focusing on what we're trying to address rather than, I think someone says, right, if you have a big hammer, everything becomes a small nail, right? That kind of thing. So yeah, indeed, for the last 10 years, deep learning, however they call it, is the big hammer, right? But going forward is much broader than that. To me, problem solving is what all students, engineering, computer science, all need to aspire, rather than fixating on one tool or the others. Okay, thank you.
Thank you.
Okay, so yeah, thanks for all for the answers. So yeah, that will be the end of our panel discussion. Once again, I would like to thank all panelists here who have joined us physically and have answered some of your questions. So I hope you guys have gained something from this panel discussion. And now I would like to pass the time back to Yinjie.
Thank you all the panelists and Mr. Sugong for the insightful discussion. And let's give them a round of applause. Thank you. And I trust all the audience, both virtual and physical, have gained some insight from the discussion. And to express our appreciation for our plenary speaker and also all the guests, I would like to invite Professor Tan Yaping, the chair of School of EEE, up on stage to present tokens of appreciation to our guests. Professor Tan, please. And firstly, we would like to present a warm thank you to our plenary speaker, Professor Chen Tsuhan. Prof Chen, please. Thank you. And we would like also to thank our panelists by presenting the tokens. Firstly, to Dr. Yao Wei Yun, please. Thank you, Dr. Yao. And Dr. Cheston Tan, please. Thank you, Dr. Tan. And Mr. Arnold Dore, please. Thank you. And Mr. Leonard Tan, please. Thank you again for all the guests for coming. And now I would like to invite our guests to take a group photograph on the stage. May I invite the panelists to take a group photograph together with Professor Tan on the stage? And could you rise and take a few steps forward? Thank you. And please look at our photographer. Thank you, Professor Tan, and all the guests. And please kindly return to the seats in front of the stage under the guidance of our ushers. Thank you so much for joining us tonight. And ladies and gentlemen, we have now come to the end of our opening ceremony. And I would like to thank both our physical and virtual attendees for joining us tonight. And next, I would like to invite the audience to join our virtual career booth happening on Gather Town. And please follow the instructions on our slides to join the career booth later. And we would like also give our warmest appreciation to our sponsors of the event, to A-Star, TikTok, Shopee, Gather Town, and Netverta, as well as all companies joining us later in the career booth. And I would like to invite our panelists and guests to take a leave first by the door on their left. Thank you so much again for joining us tonight. And next, I would like to invite our physical audiences to leave by the door on the right-hand side. And I would also like to thank you for joining us tonight. And please stay tuned to our social media and email for our upcoming events of the conference. Wish you a pleasant evening and see you later at the virtual career booth.